Hi everybody, let's talk a little bit about forces. Okay, this is just an introduction to forces. We will go much deeper into these concepts as the term goes on. But a force is something that can change the motion, direction or the shape of an object. So a change of motion can mean that a force is making something start moving or to stop moving, or to go faster or slower. A change in direction simply means that when a force is applied, the object changes the direction to what it was previously moving in. Think of a skateboarder, if you will. So forgive me if I don't get the correct skateboarding terminology, alright, but I'm a science teacher, not a skater girl. Okay, so picture this. We've got Tony Hawk carrying his skateboard. He puts it down on the pavement and he pushes off. When he pushes off, the skateboard starts in motion, starts moving. Every time he pushes, he goes a little bit faster. So every time he pushes, he applies a bit more force. When he wants to turn the corner, he will apply force to one side of the skateboard, and that will make him go in a different direction. So some examples of forces are pushes and pulls. So we've got pushes and pulls. Okay, so we can push an object, we can pull it, there's friction. Friction is the force that occurs between two objects to slow them down. So when I push the car, there is friction between the desk and the wheels. Okay, but more on that later in the term. We also have got gravity. So gravity is the thing that pulls objects down to the centre of the earth. And we have magnetic forces. So force has got two aspects. One is direction and the other is magnitude. Magnitude means it's the size of the force or the amount of force. So is it a small push or is it a strong push? Let's try that one again. Okay, is it a weak push or is it a strong push? Oops, there goes my Lego car. Okay, so forces are working around us all the time. We can stand up because gravity is pulling us down. Okay, gravity will pull us down to the ground. Okay, that is a pull of gravity. And the reason why we don't fall down is because the ground is also pushing up. So the ground is pushing us up, gravity is pulling us down, and we don't fall down or fly around in the air or sink down through the ground because those two forces are in balance. Sometimes you need a direct contact to apply a force, like when I get my little Lego car again. I've lost my person, but when I want the car to move, I apply a force directly, touching the car. So I'm pushing it with my finger. That is a direct force. But some objects don't need to be touching. Okay, so some of those things can act from a distance. So gravity is something that can act from a distance. So my pen is not touching the ground, but I can let go and gravity pulls it from a distance down to the ground. Magnets can also work at a distance. So here I will put some magnets down onto the table and watch what happens. So I've got my magnet. Now the magnet doesn't have to actually touch the magnets, the paper clips, sorry, for them to be pulled towards the magnet. Okay, let's do that one more time so you can see it. Hopefully you'll be able to see it clearly. I'm going to push the magnet slowly and see how, it's starting to move. Oh, pull them straight in. Okay, magnets can only exert a force on an object if it's within its magnetic field and it's not too far away. So a magnetic field is the area around magnets where the magnet can exert a force. So this is my cube of iron filings. So it's full of tiny little pieces of iron that are floating around in a fluid in there. So I'm going to shake that around, and then, let's see if I put that in front of the camera. I hope you can see it. I'm going to pop a magnet in the middle, and we'll see what happens to all those little bits of metal. So I've put that magnet in, and hopefully, I might be able to lift the screen up now. Hopefully, you should be able to see, if I can get this out of the glare, all of those little bits of iron filing that are starting to get sucked in towards the magnet. And you can see those little lines that it seems to be making are called the magnetic field lines. Okay, so the shape of the lines depends on the shape of the magnet, but the magnetic lines will always go from one pole of the magnet to the other. So that's the north and south poles. Okay, and we will look at magnetic field lines a little bit later in the term. It's quite fascinating the way that they change shape when they reach out towards each other. So these iron filings have all gone pretty close to the magnet now. I'm not quite sure if you can see that well, but you might be able to see the little lines that are connecting from the north and the south pole of the magnet. Alright. Okay. So all of these concepts will be explained a little bit further in coming weeks. Okay, we're going to explore them a lot more deeply in class. So let's just go over the basics one more time. So different types of forces can be pushes and pulls. We've also got the force of friction. We have the force of gravity and a magnetic force. Okay, the forces will can change the shape of an object or the direction that it's going in or its motion. What else? A force has two aspects. One is direction, one is the magnitude. So is it a big force or a small force? Is it a weak force or a strong force? Some forces need to have direct contact and some can work at a distance. I think that pretty much sums up what we talked about today in this video. So I hope you enjoyed the introduction to forces, and make sure you summarise the video and ask a question if you can. So what are the main points and what do you want to know more about? Okay, thank you.